This is the last update for chapter 5. Finally, it's been a long chapter, even though it doesn't seem that big on the sheet. I did skip a few problems at the end. I think that's going to be the rule for the rest of the book. Skip a few problems here and there. No more videos. And then I've already read section 6.1, but I'm not going to show it until I do a video for chapter 6. And of course, chapter 6 is very long, so there will be many videos for chapter 6. For the last section of chapter 5, there were 29 proofs that I attempted, and there were 36 problems. So this will go out March 19, 547 problems, 351 proofs. So, and this here is, I think is usually as a prop, but I'm also going to show, this is my other copy that I'm about to start using for the commute. I'll be reading it on the train. So this is the last section of chapter 5. And it wasn't that lengthy, but it definitely had a lot of problems. Yeah. Invariant subspaces and the Cayley-Hamilton theorem. Yeah, just all about understanding how the polynomial, after it splits, how the subspace polynomial can divide the total polynomial. That's really important. Then figuring out how to write these matrices out all the way to the point where you get into direct sums, and then you get these clean matrices, which I believe are a harbinger of Jordan canonical forms. And I'll show when I talk about the exercises, I struggled a little, so I think I'm going to make a coming back to note for this section for some of the problems. So yeah, so this is section 5.4, the reading. Of course, I'm using little coloring labeling these days. Nothing to see here except that I read it. Always try to work out the examples whenever they need working out. Yeah, that's the end of it. And then when it came to the true and false, I think I screwed up only one. Yeah, that's pretty good. Then problem 2 was okay. Problem 3 was, I tried. Some of these proofs, I just tried them. I'm not sure that they're correct. I did the best that I could. I screwed up. This is where it got weird, I believe. I think all of these problems are cyclic transformations. I am missing a couple of really good examples. I found that, see, I kept getting things wrong, even though I could tell what the whole polynomial was going to look like. It seemed to me that the easy problems were useless examples and the hard problems were useless problems, and there was nothing in between. Usually, there's an easy example for which there is a problem that's almost just like it, and you get to practice. And then it gets a little harder, and there's a harder example, and then you get to practice. And I usually sacrifice one answer and then work on the rest. I somehow could not do that, and I looked up examples on the web, and all the examples on the web for cyclic transformations were the easy type. There were no hard ones explained. So I was like, all right, I'm missing something. I'm going to leave it be. There were some easy proofs getting further down in the problems, and then some proofs I just waived. Actually, I think this is actually fairly correct, but I still gave myself a little ding. I tried as best as I could to go for the harder proofs, but some I could see, okay, yeah, I know what I need to do for this one. And then for some, I tried my own way, didn't get anywhere, tried the way that they were explaining, didn't really get it completely. And so there were a lot of hard attempts at proofs, which is what one should always do. I mean, I should always try it, even if I don't think I've got all the details correct. But every now and then there would be a proof that I was like, oh yeah, I know how to do that. I think I do. But yeah, the whole business of breaking up the cyclic transformation into a characteristic polynomial, I'm moving on, but I'm making a note that I got to come back to that. And so there you have it. That is the end of chapter 5.